Welcome to a lesson with Dr. Powell. Let's suppose that we want to determine the convergence or divergence of something like 1 over natural log n. Now, we can do an inequality asymptotic comparison, that's fine. But why don't we do a limit comparison to see kind of how that would work? Now, eventually, this thing, natural log of n is kind of like smaller than n, so you can almost think of this guy as being bigger than 1 over n, which we know diverges. So 1 over n diverges. Let's see how it compares to 1 over n. We'll take a limit. Now, if we rearrange, this is like n over natural log of n, and we're taking a limit as n goes to infinity. Use L'Hopital's rule because infinity over infinity, we can take derivative of the top is 1, derivative of the bottom is 1 over n, and that simplifies to n. So we're taking a limit as n goes to infinity. Well, that's just infinity itself, which means eventually this ratio eventually goes to infinity, which means this eventually is much bigger than this. So since eventually asymptotically we have asymptotic a greater than, and sometimes actually there's a notation for this asymptotic greater than. You can use a double thing if you'd like, and for big enough n. So that's going to be bigger than 1 over n since this ratio is going off to infinity. Since you know this diverges in a series, then this will definitely have to diverge in a series. So we've just shown the divergence of this, and maybe we should put in some things like this going on. So we've just shown the divergence of this using a limit comparison. Thanks for watching.